Cross slide lead screw is fabricated from 3/16 diameter cold roll steel, and so is the tailstock spindle screw. Because of the projection of this, the 1-inch 250, where the threads go, I'm going to cut that diameter first, the 125, and I'm going to advance it out of the collet a little bit at a time, and I'm going to creep up on this diameter lengthwise for the initial operation. I will turn the diameter for the shoulder, and very possibly I may back turn the 124 so that I do not have to hold on the 125. You can also flip it around, put it in a smaller collet, and do it that way. I'll know when I get there. Right now, I know I'm going to turn this to 125 by 1-inch 250. That's where we're going to start.
All right, we're going to go for the extended 1-inch 250 long 125 diameter. And in order to come up with a number on the cross slide, I'm going to extend the material out of the collet very superficially so that there's no deflection influence on this part. Take some emery, knock off the hairs on the part if it is not a superb finish, and then advance the part as you see fit. Right at the very last minute before the cut pulls off the part, draw the cross slide out so there's a small taper there. It makes for a much cleaner blend line. And when you know you have the number you're looking for, go for it. Move it out a little bit, lather, rinse, and repeat. When it comes time to make your final cuts, make sure your part is extended far enough that it will match the dimension on the print. Hit the tool on the end of the part and zero everything out, which I just did. And now we can go for the final length, the 1-inch 250 length. You can hit the same numbers that you've been hitting for the first 2 or 3 or however many steps it takes. But just make sure that visually the end of the part is running true. This is the 156 shoulder that's on the print. This is basically like a stop collar for the part when it's coming in from the opposite side of the cross slide. You'll see that in later videos. Little emery to take the uglies off the outside. We're going to prep the nose here for the thread. That's all she wrote. If you're going to use a file on a lathe, make sure there's something protecting the tang end of the file. A wooden ball from a cabinet pull or a drawer pull, hardware store, 90 cents, 99 cents, works fantastic. These files are a donation from a subscriber. Thank you, T. I love these files. I do not use them on edges, only on diameters. Slow the machine down, wipe off the ugly, and make everything look beautiful. Now that's the lead screw for the cross slide. The tailstock lead screw is a little bit shorter, and I'm making that on the other end of the raw material. Why part it off? You don't even have to part it off yet. You've got all your numbers set from the previous part. Just roll it around, and the only difference is the overall length.
I can expect a little bit of push off on this. I am now in 1/8 collet. I'm going to do the opposite end of these parts, and this is going to be the same setup that I'll use for threading. I can expect the very outside edge of this piece to be a little bit bigger than it is when it gets to the collar. But that's what an awesome file is for. Wipe it right down, not a problem. Let's do it.
All right, guys, anytime you're going to grab a part in a 1/8 collet and turn anything extended this far, you could absolutely expect this to deflect and push off and give you a taper. So be very gentle with how aggressively you approach this. And at the end, even if you still have a taper at the very end, it is not uncommon. It's incredibly hard to make that go away. It's okay to hit it with a file, cheat a little bit, take a couple of dead passes until you're just content that the taper is not going away, but do what you have to do. I'm wiping the OD with a file to take the nose taper off. It is unavoidable. It's not you. It is unavoidable. Unless there's a live center in it. Anytime that you do not have a stop set inside your collet, take a facing cut, take it out, measure it, put it back in, and now you have a starting place for all of your print dimensions. This is the same as the cross slide screw, just a little bit shorter on the Z-axis. The ends of both of these lead screws are drilled and tapped for a 172. I am using my floating drill chuck. Pushing this by hand, there's no mechanical interface here other than I'm just physically pushing this drill into this material. You get a tremendous feedback. If you haven't watched the video on the stop breaking small drills, go check that one out. I'm going to prep both ends, or excuse me, one end of each piece, because they both get basically the exact same preparation. And I'm using my little knurled thumb wheels, a little bit of anchor lube. And ultimately at the end, I'm going to use some WD-40 on that as well. Make sure everything's clean, blow it out. Take your time. Do not push a 172 tap when you're tapping steel.
Alright, just because there is no good camera angle to do this, there is the steel 540 single point, 1.25 inch extended. This guy worked like a charm. It did not wipe the burrs off like it did on the brass. I guess the brass is considerably softer. Here is the half nut gauge. Believe me, my eyes are doing the same thing that camera's doing. That is really smooth. Alright, well that is the lead screw for the cross slide. I'm going to see if I can get that lucky with the tailstock as well. Alright, we're going to try something new here. I got a new camera rig shooting straight down overhead, almost line of sight, but not quite in my way, so that's a good thing. This is the shorter of the two lead screws. This is the tailstock spindle lead screw, and I am going to put the 540 thread on it as we speak. You can see that the phenolic follower is going to be just slightly behind the tip of the threading tool. And if you haven't watched the video on the extended small diameter turning, watch that one. The tip of the tool is not quite as far back as the follow rest. That way the tool will traverse off the end of the part and the follow rest will still be supporting the part. That's really important, or you're going to have a very flared end right at the last minute. I did the long one first off camera, and I'm going to do this one on camera just so that you can see that it does work on steel as well. Let's do it. 425 RPM, 40 threads per inch. .540 left hand. Let's see if the gauge fits. Always double check the OD of a thread as you're turning it. The displacement of the material could potentially make it larger. And you think it's the pitch diameter that's not good, and it's the OD. Can't ask for better than that. That's pretty good. I mean, you could ask for it, you're not going to get it. All right. Next step in the operation is to put the 094 drive square on the end of both of these. They're exactly the same. Now, there's a couple of different ways you can do this. If this section is long enough, you can feed it from the back side of a collet and expose whatever you need to work on. But you can see that on the shorter of the two. And yes, I know that the collars are different thicknesses. That is by design. This one won't stick out as far as this one. As a matter of fact, that little one won't stick out at all. So you can put it in V-block. Like this one right here. Chances are your V-block doesn't have my name on it, but who knows? It might. Holding it back here by the threads, no bueno. It's going to flex. It's going to damage the threads. But it's going to rock around like this because it's got a collar on it. V-blocks don't like pieces with collars on them. That's why I have a bunch of these. I've made inserts over the years, and it allows me to hold headed pins, a variety of different sizes. And for this one, we're going to go with the little one. And you can see exactly how well that would work. But that's too easy, right? I'm not going to do it that way because on the small one, it's still not going to be enough projection on the small one. I even have a custom little bridge that I made just for this. Someday when I have a third hand, these videos will get better, but until then, just suck it up, Nancy. All right. We could do that, but we're not going to. I'm going to show you a quick and dirty way around it if you don't have a V-block and you have a couple of minutes on your hands and you can get away with something. I'll show you something cool. Let's do it.
Let's grab a piece of random inch by quarter inch 6061. Could be anything, whatever you have. Stick it in your vise and mill both sides parallel to each other. No specific size right now, it doesn't matter. Off camera, I'm going to deburr that side, flip it over. We're going to deck the other side of it off. And I still got some saw remnants in there, so I'm going to make another pass. Not even going to deburr this. I'm just going to stand it up in the vise at approximately 45, maybe 44 and a half. Whatever floats your boat. Take the exact same mid mill that you just used and cut a notch in it. Take it back over to the saw, watch your fingers, split it in half. And when you take it back over to the milling machine, you now have two handy little opposing V-block nests that you can actually mill right into. Put the part in there, indicate it true to the spindle. And let's start the squaring operation. Now, if you're going to require a really critical length feature on the end, like we're going to put here, it's not critical, but I want to make sure I hit it. When I turn this, I'll turn it maybe a thou or two longer than I need to. Right now I've got black Sharpie marker on the end, and I am decking off the end of the part with the end mill. Now when I drop the end mill or raise the table a specific amount, I know it is exactly that much from the end down. These are both 094 squares. One is a little bit longer than the other one, but because I am adding dials to mine, I'm going to change up mine just a hair. And in the closing segments, you're going to see this assembled with the handle on it that I previously made. And I'll guarantee that some of you guys are going to wear your fingers out telling me that you don't like the washers. Well, neither do I, but they're made to print. So you got to make it to print and assemble it before you know you don't like it. So I am going to take the washer that goes on the crank and make it considerably smaller. Once you know what your X and Y offset is, it is easy to just create the square. These are very repeatable, believe it or not. They're very primitive little blocks, but they're very repeatable. Alright, now thinking ahead to the end of the video, I'm going to assemble this, and I'm going to need some washers, so we'll figure we'll just knock a couple of them out real quick. I always make washers exactly the same way. I'm going to make a tube, and that constitutes turning the OD and the ID. And then I just slice them off, knowing the thickness of the parting tool. Looking for 187 on the OD, I'm about 5/10 under. Now I'm going to drill a hole in the center using my floating chuck, because I use what I show. I really like it. Gives you great feedback. And I honestly believe that if you were to do this and feel the way the metal cuts, it'll give you a much better feel for the compound and the cranks and the dials. You need to feel the cut. On a parting tool like this, I'm going to just dust the front off, and knowing what the thickness of the tool is plus the thickness of the part, that's your stack dimension. Give it a little bit of a kiss like that and deburr the corners, because you're not going to get a chance to hold this again. And hopefully the remnant leaves on the stock and not the part. But if it doesn't, you're going to need to come back and you're going to need to change the angle of the front of the tool. Hopefully, here we go. Wait for it. Just like that. Boom. Yep. And through the magic of video editing, the tool is reground, and we're going to go back in. So watch the washer drop off before the remnant. Washer's loose, remnant's loose. Nice clean part. All you need to do is deburr 2 IDs. A little bit more of a kiss. 2 deburrs on the OD. Finish the cut. You can do this all day long. It's a great way to make similar parts.
A good way to retain small pieces when you're done with them, bend up a paper clip. Stick them on a paper clip. Make sure you bend it back so they can't fall off. It's a lot easier to find a paper clip than it is to find one of these little guys. It's about 4 millimeters in diameter, about 3/4 of a millimeter thin. About a 1.25 millimeter hole through the center. So that is a 5/64 ID, 187 OD, 1/32 thick. Tiny. I like it.
Alright, for all you guys that are about to wear out your fingers typing that you do not like the size of the washer compared to the screw, compared to the handle, blah, blah, blah. I get it. But this is being done per print, and you can't make something better until something is made. So when I'll screw this down, I will say no, the size of the washer is way too big for the size of the handle. So when this comes to push comes to shove, I will make that smaller and I will make it ornate. Trust me, don't put that in the comment.